Okay. In this problem, we want to find the forces in member HI, which is this member right here, HB, which is this member right here, and BC, which is this member right here. So if I'm only trying to find a couple of these members, I don't need to do the joint analysis, which is pretty tedious. I can do much more direct route, which is the method of section. However, the first step I need to do is find those reactions just like before. So we'll start with that before we get ahead of ourselves. We'll go AX and AY, and then we've got E over here. Okay, so if I sum the forces in the x, well, the only thing I've got there is ax equals 0. That's the only horizontal force I've got, so essentially this ax is non-existent. Okay, so don't have to worry about that based on the loading. So in the y direction, I've got ay, I have e, and then I have negative 30, negative 20, negative 20, negative 40 equals 0, just like that. And then I've got the sum of the moments. I'll do it about point A since there are two forces there, even though one is 0. Okay, 30 also goes through it. Okay, so I'll start with my E, 16 meters over, so it'll be 16 times E. And then I'm going to have these three other moments, right? The 30 kilonewton goes right through A, but I've got the 20, 20, and the 40, right? So, and these are all going to be negative. So that's going to be negative 4 times 20, negative 8 times 20, and negative 12 times 40, like so, equals 0. From that, I learned that E equals 45, and I learned that AY then equals 65. Okay, so I've got those reactions, okay? Now, we're going to do what's called the method of sections to figure out what those members are. And what I do is I basically make a cut, and I can only cut through three members. I have to cut all the way through, okay? And I can only go through three members because I'm only going to get three equations. I'm going to get two force equations and a moment equation this time. So I make this cut right there, okay? And I'm going to basically separate this, thereby making those internal forces that I had now external, okay? So I'll have this side here, right, where I've got AY, which I now know is 65. I've got 30 right here, and I've got 20 right there. And I've got these forces. I'm going to assume they're all tension, so they're all going to be outward. That'll be FHI, and then I'll have FBH, and then I'll have FBC. Okay? I also have the other one. Okay? Okay, which will look like this. Okay? I'm going to have 20 right here. I'm going to have 40 right there. I've got my reaction at E, which I've calculated, and it is 45. Okay, then I've got the same forces. I'll assume they're in tension. F, B, C, like this. F, B, H, so they're all equal and opposite of the other one. And then F, H, I, like this. Now, at this point, I drew both of them. Okay, we only need one of them, but I do want to represent that you're cutting it, separating it, and you've got two halves. You can draw either half. I'm going to do the left half, and that's just because it's smaller. Okay. Uh, there's lots of different reasons you choose one half over another. You can't be wrong though, which is the nice thing about this. Okay. But I'm going to go ahead and do the left half because it's smaller. Okay. And what I'll do here is I'll go ahead and I'll sum the forces, sum the forces in the x direction, and I'll have that FHI, I'll have FBC, okay, and these are all 45-degree angles, 4 by 4, so I'm going to be a little sloppy with it. Sines and cosines are the same, but I'll call this FBH cosine of 45. Okay, those are all my horizontal components that I've got there. So set that equal to 0. They're all to the right. FBH is at that cosine of 45. Okay, move on to my y direction, which will have 65. I'll have minus 30, and I'll have minus 20. And I'll have plus FBH sine of 45. Okay, then I'm going to go ahead and I have a moment equation. Now I get to choose a point, and the best point to choose is B because that is that point right there. I have two unknown forces acting at that point. They both go away, so I'm only going to have one unknown that's going to show up here, which is going to make my life a lot easier. Okay, recognize I could have also chose point H over here off of the member. It doesn't have to be on the member. Sometimes it's best to choose something off the member. I don't need to do that here. B is just fine. I'm going to stick with that one. But just recognize H would have been a pretty good choice as well. Okay, so now with this one, I'm going to have negative 4 times 65. And then I'm going to have plus 4 times 30. The 20 is 0. FBC is 0. FBH is 0. So I only have negative 4 times FHI. And those equal 0. So now from this, I can go ahead and solve these three unknowns. So here I can find FHI. And when I do that, I find it to be negative 35. From here, I can find FBH, which I get to be negative 21.2. Plugging those two values into this top equation, and I can find FBC equals 50. So once I do all of the solving, then I go switch them to tension or compression. So this guy becomes 50 kilonewtons in tension. My assumption was correct on this one. These two assumptions were incorrect, so I'm going to call that 21.2 kilonewtons in compression and call this one 35 kilonewtons in compression. So with the method of section, find your reaction forces, make a cut that goes through no more than 3 unknowns, but you got to cut all the way through so you can separate them out. Choose one half, probably the easier half, draw that, expose those cut forces, assume them all to be tension. That section is going to be in equilibrium, so you apply your equilibrium equations and solve up to those 3 unknowns. If you get a negative answer, that assumption of tension then becomes compression. But do that once you get all the way through the math, just so you don't get confused about what's positive and what's negative as you go through things.